Hi, you're back with Andrew. We're doing some stats homework tonight, working in the areas of probability. The next exercise I have to do is non-mutually exclusive events. I use an online tool called cram101.com, which I found is kind of neat because it gives you the formulas. Everything is already formatted for you and laid out, so you don't have to mess with spreadsheets. So let's go to Cram, and this is the stats lab menu on Cram 101. What we're looking for is probability, what you got, and then non-mutually exclusive events. Okay, so it starts out with a formula. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of their intersection, A and B. So the first thing they ask you for, they do this by using dice. It's kind of cool. We'll use 2 dice in the trial, and you can go with their roll or you can re-roll them if you like. It's pretty simple. So the question is, what is the probability of rolling a 3 or 5 with a single roll of 2 dice and in any order? Okay, so the first thing we want to do is determine the number of possible outcomes. So each die, as we know, has 6 sides. And there are 2 dice in the trial. Since each die is independent, each will have its own number of possible outcomes. So what that means is for each dice, there's 6 sides, and the 6 sides are all different. Therefore, there's 6 possible outcomes for dice number 1, and there's 6 possible outcomes for dice number 2. So what are the number of successes? Okay, to roll a 3 on a die, there is only 1 possible success. To roll a 5 on a dice, there's only 1 success. So now we need to calculate the probabilities. Okay, so again, our formula, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So our A's and B's represent the 3 and the 5. So the probability of a 3 or a 5 is equal to the probability of getting a 3 plus the probability of getting a 5 minus the probability of getting a 3 and a 5. So simple probability formula is the number of successes over the number of outcomes. All right, we have 1 dice. It's on 1/6 is the number of successes over the number of outcomes. So that translates to 0.167. Same thing for die number 2, 0.167. And the probability then of getting A and B, a 3 and a 5, is 0.167 times 0.167. Okay? So now we just carry out the math. So, excuse me, 0.167 plus 0.167 is equal to 0.333. And the product here of the two, 0.167 times 0.167 is 0.028. So do the subtraction, and our probability is 0.638. And that's how you do it. Thank you.